Consider this equation. X squared minus 8x plus 15. Show numerically that x equals 5 is a solution. How do we do that? Plug it in. 5 squared minus 8 times 5 plus 15 equals 0. 5 squared is 25 minus 40 plus 15 equals 0. Well, 25 minus 40 is negative 15 plus 15. Oh my gosh, 0 equals 0. So 5 is a solution, correct? But there's another solution. So let's use the table to help us figure out the other solution. So what they want us to do is this for every single one of these numbers. You know how I feel about that. You understand the math. You know what's going on. You just proved to me that you know what's going on. Okay? So let me go here. And we're going to add a graph. X squared minus 8x plus 15. And I'm going to look at the table. Control T, remember, will pull up the table for you. Okay? So 1 is, when x is 1, y is 8. Is that a solution? How do you know that the answer is no? What makes it a solution? If y is 0, okay? So 2 is 3. Is that a solution? No. 3 is 0. Oh, yes. Let's check 4. Negative 1, no. Is 5 really a solution? Yes. And what about 6? 3, no. Okay. So, use the table above to plot the points and sketch the graph. Okay, there. Which 2 points represent the solutions to the original equations? Guys, if we plotted these points on this graph, like it asks us to, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3. 3, 0. 4, negative 1, 5, 0. Negative 3. Guess this one will be up here. Now, I kind of cheated a little bit, and we actually talked about this a little bit yesterday. I know you're upset at me. I can tell by the back of your head. Which 2 points represent the solutions to the original equations? By looking at the graph. What are they? 3, 0 and 5, 0. Where are both of these points located? They're on the x-axis. What did I tell you yesterday? Where the graph crossed the x-axis was the solutions, right? Do you remember that? At least 2 of you do. Excellent. Okay? We are going to talk about 3 different ways to solve quadratics. The graphs and tables, factoring, and the quadratic formula. Okay? This particular worksheet deals with the graphs and the factoring. The next worksheet deals with the quadratic formula. Okay? So, we're going to use the following terms to describe the solutions. And again, we talked about this yesterday because I was trying to push us. Okay? So, when we're talking about something like this, which is called an equation, when we're dealing with an equation like this one with x's but no y's, do you see any y's in here at all? There are no y's in here. The answers that we get are called solutions or roots. So the solutions would be x equals 2 and x equals 4 to this particular problem. Okay? Now, in something like this, when we're given a function, either a graph or an actual function like this, these answers are called zeros or X-intercepts. Here we would have to say the zeros of this function occur at x equal 2 or x equal 4. And depending on what book or what worksheet or something we're talking about, even this may not be acceptable. It may have to be something like this because it is an intercept, isn't it? It's not just a number. It's not a solution. We didn't solve for x and get x equal 2. We looked at a graph and saw a point on a graph, so our answer is written as a point. Does that make sense? Okay. Look at the next page, please. It's giving us lots of different things to fill in. Okay? Look at problem number 1. Here is the factored equation. Okay? If this is the factored equation, what is the expanded equation? Glance up at the example if you need to have a general idea of what to do. What's the expanded equation? X squared minus 3x minus 4. Now, if you'll remember, we talked about the fact that we can skip that middle step if we need to, can't we? Because we can do some of this in our head. X times x is x squared. X times positive 1 is 1x. Negative 4 times x is negative 4x. So a positive 1x and a negative 4x is negative 3x. And then negative 4 times positive 1 is a negative 4. Does everybody see where that came from? Okay. What does the graph look like? What could we look at to check? Oh, excuse me. So we could check something that we know, which is our calculator, right? Oh, but I also heard somebody saying something else. Jenny, what were you saying? It is parent function shape because there's no multiplier. The y-intercept is at negative 4? Is that what you said? Do we know anything else? Would it be the vertex or is it just the x-intercept? I could do negative b over 2a if I wanted to find the vertex, couldn't I? Guys, if this is my factor, what is my solution? Positive 4 and negative 1, 0, right? So 1, 2, 3, 4, and 1. So what's it look like? Jordan, does this answer your question? Is that the vertex? Does that make sense? We know it's not the vertex because it's not what? Halfway in between these two. Doesn't it have to be halfway in between those two? Okay, thank you. So is it going to look something like this? Oh my gosh, I didn't even look at my calculator. I must be doing it wrong. Yeah, I'm not. Okay, so what are my zeros? Now, a second ago, Jordan told me that negative 1, 0 and 4, 0 were my x-intercepts. Are those my zeros? If it's asking for zeros, what is it asking for? X equals something, right? So x equals what? 4 and negative 1, right? How are zeros related to the factors? That was J, right? That's what I made you do J for yesterday. Did you get that? 3 people. Excellent. Okay, so what about the table? Negative 1, 0, 4, 0, and 0, negative 4, right? And where'd you get that? Y-intercept. Okay? So, I want you to circle 3, 2, 3, and 4, actually. Okay? And I'm also going to have you circle 5. 5 is different, isn't it? What do you have to do? You have to factor it, right? Okay? Turn it over, please. How is each factored equation related to the zeros? Okay, let's have our third conversation about this. Are you getting the idea that this is an important question? How is each factored equation related to the zeros of the related function? You want me to tell you the math language? Here's the math language. If n is a zero of the function, then x minus n is a factor. How's that? Now, when I said math language, some of you freaked out because you're like, oh, great, it's going to be words we don't understand. Guys, that's a math language. Is that hard? No. We're good. All the vocabulary words we know, right? We've gone over them. Does that make sense? Is this what you were trying to tell me earlier? Yes. Okay. All right. Equation 3 and equation 4, we haven't done those yet. You're doing those tonight, so you need to do 8 and 9 as well tonight. Okay? So, what time do we get out of here today? Is it time? Okay, almost. I can get, okay, good, we're good. We can get most of the way through this. We're good. Okay? I know we're only on the 3rd page of 6. We're good, I promise. 3 possibilities. This is the fundamental theorem of algebra. Does that sound important? Guess what? It is. That a polynomial equation with degree n has precisely n complex roots. Don't worry about this vocabulary word. We will get there either tomorrow or the next day. Okay? What is the degree of a quadratic equation? Do you remember what degree means? Highest exponent. What's the degree of a quadratic equation? 2. How many complex roots should it have? 2. Where are the complex roots here? Here's one, right? What about this? It only has 1, but this is what you need to know. It's a double root. And what about here? There are 2. They're imaginary, and I'll leave it at that. We'll talk about that tomorrow. Look at the next page, please. These sample problems, I want them done. Okay? Sample problems. Any questions? Have a great day. I'll be here after school if you have any questions. Come and see me.